This is LeetCode. It's a programming website with a lot of coding problems that prepare you for tech interviews. And this is me. I've never solved a LeetCode problem before and am unemployed. That's why I'm going to attempt to solve 100 LeetCode problems no matter how long it takes. I want to become like that guy, Malin, who is a ping pong Olympic champion and he's also insane at it. Well, mine is a ping pong because I suck at ping pong. Alright, let's create my LeetCode account. Seems like green code is taken, so what about that green coder? Yeah, cool. Let's go. Let's quickly upload a profile picture and voila, we have a profile. Great. And as you can see, we're ranked 5 million in the world, which is a bit discouraging. And we have solved 0 out of 3,294 problems. Oh god, this is gonna take so long. Right, let's start with an easy question. If you've never done LeetCode before, there are 3 types of questions. Easy problems, which introduce you to the topics of pointers, stack, trees, like this one or this one. Then there's medium problems, which apparently are quite difficult. And then there's hard problems, which are impossible and make you want to smash your computer. Unless, of course, you're Malin, who is 0.01% of the entire website and has solved 675 hard problems out of the 745 on the entire website. Oh, what's that? Oh, he just solved one more like 5 seconds ago. This man is insane. Anyway, let's start off with an easy question. It's called contains duplicates. So they give you a list of numbers and you have to return true if there's a duplicate in the array and return false if there isn't. Cool, let's do that. Wait, what? I have to code in C++? Nah, I'm not doing that. Don't mind me just switching to Python real quick. Okay, this should be fairly simple. All I have to do is keep track of the numbers that have appeared and check for duplicates. Now I could sort the array to do that and then check, but that would be kind of slow and inefficient. Instead, I can just use a set, which is way faster. Okay, let's quickly do that and boom, easy peasy. Let's run it and I'm sure nothing wrong is gonna happen. Oh well, okay, yeah, I got it wrong. That's embarrassing. I forgot to add the return statement at the end. Okay, fix it and boom. That's our first LeetCode problem right there. And if we go to our profile, you can see that it's updated. Let's go. Only 99 problems to go. Shit. Now, if I really want to solve 100 LeetCode problems, I need a strategy. Because I quickly found out after a couple of hours that if you just try random problems, it's chaos. One problem can be super easy, but then the next one is talking about linked lists, which I don't even know what they are. And then there's a tree problem. It's all over the place. And then in the middle of all this chaos and despair, I found NeetCode. This guy is awesome. He's a software engineer turned YouTuber that helps people get better at LeetCode. And a few years ago, he created the rule. I don't know why that was so dramatic. But anyways, it's a collection of 150 LeetCode questions grouped by topic with a free video explanation on each one of them. Seriously, this guy is amazing. So here's the plan. I'm going to try and solve 50 questions out of this roadmap and then sprinkle in 50 other random questions. I also want to practice these topics because they look cool and they seem like the building blocks for more advanced shit. And by the end, I hopefully can be as good as my hero, Malin. Alright, let's get to work. The first topic is arrays and hashing, which I'm pretty comfortable with. An array is just a list of elements, and hashing means turning data into a short code to find stored items quickly. For example, if you want to store information about this car, you can create a dictionary with the information about the car. And boom, anytime you want to know something about the car, you get that information really quick. If you want to go all technical, you can say that it has O1 or constant time complexity. But yeah, you get the idea. Alright, enough chit chat, let's solve some LeetCode questions, baby. My next question is 242 about the anagram. They give you 2 words and you have to find out if they're anagrams of each other. An anagram is just a word made by rearranging the letters of another word. So for example, the word anagram is an anagram of nanoram. Sorry if that sounded confusing. Other examples are save and base, state and taste. You get the gist. One way to do that is to create 2 dictionaries with the frequencies of each word, and then you can compare them. You can also be cheeky and solve this problem with 1 line of code, but that's kind of cheating. We don't talk about that. Alright, 3, 2, 1, solve. And what I find really cool is that you can see what other people did and how fast other people's answers were. And so far, we're not looking that bad. We're average, but at least we solved it in 38 milliseconds instead of taking hundreds of milliseconds like some people over here. Alright, let me try to solve my very first medium problem, 36 valid syllables. You get a bunch of numbers in a Sudoku and you gotta determine if the Sudoku is valid, which is another way of saying that you can't have repetitions in a row column or 3x3 subbox. Not gonna lie, this one stumped me a little bit. I think I tried some recursion functions that didn't really work, but in the end, I found a decent solution. You initialize sets for every row, column, and subbox, and simply check if that number that you're checking is already there. If it is, you return false, but if it's not, you add it to the set. Easy peasy. 3, 2, 1, boom, accepted. And yeah, it's not the fastest solution, but hey, I'll take it. And before I knew it, I was done with the reason hashing except this problem because I couldn't be asked to do it. And I also sprinkled a bunch of other random questions for a grand total of love LeetCode questions. Woohoo! 12% of the way there. Let's go. That took me like 4 hours. Next up is stacks, which I'm vaguely familiar with, but not too comfortable with. And a stack is just a data structure that works like a pile of books. Actually, let me show you. Now, to remove this book, you first have to remove all these other ones. So, the most recent book has priority. And yes, I went to the library at 11 p.m. to get the shot. For example, let's look at 20 bulk parentheses, which is a problem I had a lot of trouble, as you can see here. They give you different combinations of parentheses and curly brackets, and you have to determine if they're correctly closed or not. So for example, this will be valid and this will be valid, but this and this will not. The best way to solve this problem is to create a stack, and each time you come across an opening parenthesis, you add it to the stack. And then each time you come across a closing parenthesis, you check if it matches the last element of the stack. And if it does, you remove or pop the last element of the stack, and if it doesn't, you know it's not valid. You do this until the stack is empty, and voila. To be honest, these stacks problems were a bit challenging for me. You literally can see it here by the number of wrong attempts I submitted. But after a lot of coding and admittedly looking at a couple of solutions, I finished the 6 freaking stacks, and there it was, staring right back at me, my first hard LeetCode problem. I was feeling pretty good about my stack knowledge, so I tried coding a solution. So I coded, and I coded, and I kept coding, and I couldn't do it. I was stuck for like an hour and a half on this freaking problem and I couldn't solve it. I even watched the NeetCode video solution, and at that point, I don't think I could have come up with the solution myself. But don't worry, because it's 2 pointers time. Let's look at an example. 11 container with most water. They give you a list of heights, and you have to figure out what 2 heights would make up the largest container if it were filled with water. Now you can do this the slow way and calculate the area with a double for loop, or you can use 2 pointers and find it much faster. You assign a left pointer at the beginning of the array and a right pointer at the end, and at each step you calculate the area until they meet each other. And if the left height is higher than the right height, you move the left pointer to the right, and otherwise you move the right pointer to the left. Easy peasy. I then solved some other medium 2-pointer problems, and there it was again, a hard problem. So I coded and I coded and I kept coding until I solved it. Just not in the way you might think. You see, this is how fast other people have solved this problem. 31 milliseconds, 78, but the average seems to be around 100 or 120. I'm all the way over here. My solution took a whopping 2,923 milliseconds, almost 3 seconds. So yeah, turns out I was using a horrible and super slow approach, while the solution was way more elegant and ran in event complexity. So although I had solved a hard problem and it showed on my profile, I didn't actually feel like I had solved a hard question. The LeetCode problems I was attempting were getting harder and harder, and my dream of becoming like my hero Malin was rapidly fading away. And then I did some binary search problems and it was all good again. Binary search is actually pretty cool. Here's an example. Imagine you have this really long list of numbers in increasing order, and you're trying to find the number 73. You could go through each number until you find 73, but this would be quite slow. Instead, we can start in the middle of the array, check if the number you find is bigger or lower than 73, and based on that, we can eliminate half of the numbers. And if you do this a couple of more times, you end up finding 73 really quick. So I finished most of the binary search problems while also sprinkling them kind of random and easy problems. I was picking up momentum, and I even started doing some sliding window problems. And this is when I decided to take a break for like a yeah, I know, not ideal. But by the time I came back in the beginning of September, I had completed 62 out of 100 LeetCode questions. And I decided to set myself 2 final goals: getting to 100 LeetCode questions, because you know that's the whole point of the video, and trying to solve 5 hard problems. And when I say trying, I mean trying. This day, the 4th of September, I solved 2 LeetCode problems. This medium problem, which took me like 20 minutes, and then I spent like 3 hours on this one LeetCode hard. look at this. What is this? And at the end of all this effort, I got this, which is just humiliating. Everyone's solution's taking like 100 milliseconds and mine is taking 900. Ah man, LeetCode is hard. Thankfully, I then reached the wonderful world of linked lists and trees. And man, do I love trees. I think they're my favorite data structure. Look at this recursive traversal of the tree. Ooh, look at this. Yummy, yummy. I love solving tree questions. I'm not kidding. I actually have so much fun doing them. It's also super cool because once you learn a couple of algorithms like BFS and DFS, which are algorithms that let you traverse the tree in a certain way, once you learn about those, the questions become so much easier. Alright, let's get back to the LeetCode grind. Let's look at 226 invert binary tree. They give you a binary tree like this one, and bada bing bada boom, you have to invert it. And there's two ways to do this. You can use DFS, which is what I did, or do it recursively. DFS is an algorithm that goes through each round of the tree as deep as possible until it has visited every node in the tree. That's one way to do it, but if you do it recursively, you can turn all this code into just this, which is pretty cool. At this point, after completing most linked lists and tree problems, I was sitting at 89 questions, which I'm really proud of. However, I was still missing 3 hard questions. So since I love trees, I searched for hard problems that include trees, BFS, and DFS. And I found this, vertical order traversal of a binary tree, which is a bit complicated to explain, but basically you have to organize the nodes of this tree into different sublists depending on their position. So I used BFS to traverse to the tree, and after 2 hours and lots of attempts, boom, it actually got accepted. And look at this, their runtime is actually pretty good. So for the first time, I can actually claim that I have solved a hard LeetCode problem. And from then on, things got easier. I solved another hard question about serializing and deserializing trees. To be fair, this one was way easier though. And after sprinkling some medium questions, I was at 99. And I faced my final hard question. And you know what? I solved it. And with that, I solved 100 LeetCode questions. Whoa, let's go. And yeah, in the end, that did not become like Malin, but I think I did pretty good. Here are some final stats. I ranked at 981,489 in the world. I solved 50 questions from the NeetCode roadmap and 50 random questions. I solved 57 easy questions, 38 medium, and 5 hard. I beat 80% of users on easy problems, 70% on medium, and almost half on hard. And yeah, that's pretty much it.